Good afternoon, everybody. I'm Dave Amato, and I want to welcome you to our sixth and final webinar in the DDI Design Webinar Series. This session is going to discuss plan detailing, public involvement, and constructability. And once again, we have Brian Toombs with Burgess and Nyepel as our presenter. So Brian, now the floor is yours. I'll pass it off to you.
Thank you, David. Can you see my screen, my cover slide?
I can, yes.
You can. Okay, terrific.
Yes.
All right. Everyone, thank you so much. As David said, this is the DDI webinar on plan detailing, public involvement, and constructability. We added that topic as well to this one because otherwise it was a little light. And give me a second to get moving here. So as a reminder, this was a 6-part webinar series on pretty much all things DDI, starting with the overview, hitting geometric design, sign and pavement markings, traffic operations, multimodal accommodations. And today we're hitting the last one. So, and again, as a reminder, you know, our two presenters, David Amato that you just heard, the FDOT roadway design engineer, and then myself, Brian Toombs from Burgess and Nyepel. We also have Randy Kill, who's also from Burgess and Nyepel. He's available in case you guys have any questions on the traffic operations or anything like that. As a reminder, the logistics of this webinar series, upon entry, you're muted. And then if you want to ask questions, please do so in the questions dialog box. Both David and Randy will monitor the questions and interrupt me as they need to. I also want to quickly apologize. It's the start of the college football season. My voice is a little raspy, so if I do clear my throat, I apologize, or if I have to take a break. But let's get rolling. So as you can see, the agenda is going to be pretty full. We're going to talk a little bit about plan detailing. We're going to roll then into constructability, where we're going to talk specifically about construction phasing, as well as maintenance and operation. And then we're going to get into what I'll call public outreach, which is the education and the involvement. And then we have just a little bit of time, hopefully at the end, for what I'll call the cleanup session. You know, with this being a 6-part webinar series, hopefully if you guys have enjoyed this throughout and you've stuck to it, congratulations to make it through all 6. But if you had questions that maybe you weren't getting answered, this would be a time at the end, hopefully, to ask those questions. So let's start with plan detailing. Excuse me. So, you know, when you think about the final plans, what should the plans contain for this, you know, for a DDI? You know, one of the biggest things we want to make sure we do is hopefully reduce that duplication of information. You know, DDIs are an innovative solution. They're very, you know, they're atypical as far as alignments, atypical as far as cross sections, that sort of thing. And so what we always try to do is, you know, wherever we can, avoid duplication, because the problem with that is if you make a change late in the design when you have it showing up in multiple sheets and you forget or you miss one of the sheets, that's where a contractor can come back at you and say, well, sheet X here showed this amount, you know, this is what we bid. And that can be costly. So one of the strategies that I have done on plans is right behind the title sheet is this sheet right here that you can see on your screen. You know, it's the smaller inset is kind of a legend, if you will, that shows those detailed areas, which are obviously the crossovers. But the larger area to the right kind of breaks down the different types of sheets in the plan set. You know, schematic plan, typical sections. And again, this is for a different state than Florida, so the names are probably a little different, but hopefully the idea is the same. The column on the left would be pertinent information in a plan set. And then what we've done is we've kind of identified both to the contractor and really to the design team, you know, where is this information being reflected? So the baseline curve data, for example, is in 3 locations and only 3 locations. The pavement tapers are shown in 2 and so on. And then this will help us as information changes due to comments or anything like that, then we can come back through and make the change to the plan set, hopefully efficiently and not miss something. So another thing that we obviously want to do is reduce the confusion. Again, innovative solution. There's not even a ton of contractors that have built these. So whatever information we can give to the contractor, give to the review team, to make it easier for them to follow. So one of the things that I really want to focus on, is when we set our horizontal geometry. So it's very easy to essentially establish 3 baselines. So the one, here, I'll back up one. The one that is pointing to right now is what would be the center line of the road. And this would be likely used for right-of-way. It could be your center line of right-of-way, something to that effect. Your plans could be detailing off of this if you were really looking to, again, detail something outside of the or for the right-of-way. The other thing I'd recommend then is establish a baseline for each direction. So eastbound and westbound all the way through the interchange. Now, the one thing that this plan set did not do that I would recommend is change your stationing such that it's very obvious which, the stationing goes to which baseline. So in this particular case, we started at about the same exact point. So station 15 plus 00, for example, I don't know if you guys can see it on the left side of this image, is pretty much in the same spot for all 3 baselines. So what you might want to do is start one of your baselines at 100, start your next one at 200, start the next one at 300. And then it's pretty obvious as you're detailing plans, oh, I'm on station 312, that's got to be the eastbound direction or something to that effect. So that's just something, again, to help out reducing confusion. Another thing to remember when we're plan detailing is we establish cross sections through here. So what you see right there are basically pattern lines that would be established along the center line of right-of-way. Okay, that center alignment that we established. The problem is if we establish cross sections through here on these pattern lines, then we run into an issue with a lot of skewed roadways, skewed grading, and it's really not as easy to detail or to quantify. And so recommendation then would be if you're showing cross sections, show them radial about the directions along each of the directions of travel. So the baselines along each direction. Another area to focus on then would be these interior areas where we potentially would look at grading plans or something to that effect. Again, what we're trying to do is define more succinctly to the contractor, what does the grading, what does the cross slopes look like, what does the ditch line, that sort of thing. So just take that step back, think about what are we trying to detail and what's the best way to convey it. Another area to look at when we're looking at reducing confusion, and this is a good example right here, is even something as easy as your striping plan. So, with a DDI, your striping plan is a little challenging because typically what happens is your lanes are widening to accommodate truck turns, that extra pavement width. And this example that you see right here is a 2-lane ramp. But none of the lines, your edge of pavement, your edge of shoulder, your other edge of pavement, none of these lines are parallel to each other. They're all a very different geometry. And so trying to even establish your striping lines is very difficult because at the same time, they're all different relative to, say, that baseline. And when that happens, we want to try to get this as accurate as we can because there's a reason why we did this extra pavement, say in the middle, that striped hatched portion, is because the trucks need it. And so we got to make sure that we get it pretty accurate. The other thing is this ramp, the total width of this ramp out to out at the widest point is about 44 feet. If the striping is not well done through here, you could potentially see 3 cars sitting here. And if you had 3 cars sitting here with only 2 receiving lanes, that's a problem. So what we have done in the past is we've actually established horizontal COGO elements, horizontal geometry for each of the lane lines that you see in that bottom right. And then we put a table up in the top left. And, this may be overkill a little bit, but it certainly does reduce that confusion to the contractors that are trying to build it. So again, just something potentially to think about, especially when you get in some of these really challenging ramps, where you've got a lot of varying widths, tapers, and that sort of thing. This is pretty easy to do anyway. You know, another thing that we can do, which, you know, again, our Open Roads Designer, you know, the latest CAD software that we have, is utilize proposed surfaces to convey grading and drainage. You know, this interchange configuration, being unique as it is, it's got a lot of warped pavement. So it's pavement that's kind of bending around. It's coming to very acute intersections. You know, just trying to track how that looks from a pavement cross slope standpoint, as well as a grading, is very important. So here's an example of just, you know, what a grading plan could look like through the trumpet area of a DDI. And again, this is really designed to help the contractor. You know, there's a finite spot where we want to put this low point, where we want this ditch, where we want to drain this thing, and where your drainage structure is. And so establishing that using your software is a good strategy just to ensure that what the contractor builds is what we wanted to have happen here. And this is another example here, you know, cutting your proposed surface across your pavement. You know, again, especially when you get to the crossovers, and we'll talk a little bit about this in a minute, but when you get to the crossovers, you're warping the pavement. You know, there could be a vertical profile difference as well, especially if it's a DDI that's going over a freeway. You're warping the pavement at the intersection. You're trying to get out through the approach curvature or the departure curvature. And so setting that proposed surface is a real huge benefit to ensure that you're getting the positive drainage and that the drainage structures you're placing is in the right spot. So this actually is an example of a project that we did where we screwed up initially, and luckily this didn't make it to the contractor. But what you see in the red with the X's on it is where we originally had the drainage structures for this and the pipes for this crossover that we were designing. And we later went back and we built a proposed surface because something didn't quite smell right when we were looking at the drainage. And as we got into it, we realized, look how much a couple of these shifted. And again, that's just simply because the pavement's being warped, the crown line's being shifted, the width's changing a little bit, and we're getting, you know, closer and closer to that crossover. So you can see that the two drainage structures shifted quite a bit. And when they did, it changed the lengths of these pipes. Now, had this gotten to construction when this happened, this could have been a big cost, because especially if they poured the curb, they've already put the drainage structure in, and then we move it, you know, 50 feet and 45 feet or whatever it is. That's a big cost to the contractor, and he's going to make sure that he gets his money's worth on that. So definitely a proposed surface is very beneficial. Again, the software we have does this pretty easily. It's just a matter of making sure that it's done. And we talk about the crossover intersections, just something quickly to remind. We talked about this a little bit during the geometric design webinar, but this is where those proposed surfaces really come in handy. So there's a couple of options on how to address the cross slopes through the crossover intersection. You know, one way is to tabletop the crossover intersection like this. And in this example right here, the approaches are all sloped in the direction you would expect for a typical horizontal curve, and then a rotated near flat through the intersection. And so basically you create this single plane through the intersection. And doing this allows us to drain the entire intersection to the west in this particular example into this quadrant area over here. And the reason why this works so well is because this was the DDI over, which meant we had that longitudinal profile grade to carry the drainage through the intersection. That's what that arrow to the left is doing. And the tabletop in the intersection provides a more comfortable ride for the vehicles because they don't have to cross that crown line. So doing this allows you to pick and choose which quadrant to best receive the drainage. You can choose this based on site constraints, ease of construction, that sort of thing, about where you want to place your drainage structures. So if you wanted to, you could have tabletop this and drained it, to the top, to the bottom, wherever. In this particular example, we drained it to the left. And then another strategy that's often used is this one, where we establish that crown line through the intersection, and it's through the center. And then with this crown line, we could slope the approaches away from the crown line like this. So this is commonly used when we have a DDI under, and we don't have a lot of longitudinal profile grade to carry the drainage to a specific quadrant. This strategy lends itself well to part width construction of the crossover intersection, with the phasing line being along that dashed crown line that you see. And this would require the driver to traverse the crown line through the intersection. One thing to note, and something that we see a lot as a common practice, in order to establish the crown line through the intersection, the cross slopes for the curves approaching the intersection are established at an adverse crown. In other words, they're sloped away from the center of the curve, typically using no more than normal crown. While this may be counterintuitive, remember that we're trying to establish slower speeds through this crossover intersection, which is a good traffic calming measure. As reviewers, remember that these curves are not designed as if we're along a freeway, but rather are purposeful in reducing speeds and establishing a good alignment for the drivers through the crossover intersection.
Hey, Brian, is this a good
Yes.
chance
Sure.
for a question break?
Absolutely.
Is there an advantage to flanking inlets and transporting pavement / slope, transitioning pavement / slope?
Yeah, there is. A little bit of it's going to certainly depend on, how long is the flat area. If I think I'm understanding the question correctly, sometimes, especially when you're rotating the pavement at the same time the vertical is being adjusted, you may end up with a flat spot, quote unquote, that's pretty long because of the flatter grades. And so you may want to look at potentially having a couple of them closer together, one right at the low spot, but then one fairly close on each side. A trench drain would work too. You just got to be careful about maintenance on that. So, because the problem with some of these is they get cluttered with debris, and if that's the case, then they become pretty challenging to work with. So, but yeah, I mean that's a good question. There's definitely different strategies for how best to handle the drain, especially in these flat spot areas. Anything else, David?
No.
All right. So sticking with the plan content, one thing I also would recommend is utilizing the proposed surfaces to reduce the construction cost and improve constructability where possible. And here's an example of that right here. So what you see here is a heat map. Using one of these allows us to optimize the proposed profile in order to closely match the existing pavement and reduce the amount of full depth pavement reconstruction approaching the crossovers. We recognize that oftentimes the crossover intersections will most likely require full depth reconstruction. Whatever we can do to minimize the full depth reconstruction and maximize that cross slope correction pavement resurfacing outside of these crossovers will improve constructability. It's going to reduce construction duration, and it's going to reduce construction cost. So to do these heat maps, simply create a proposed surface from your profile, like we talked about in the previous slides, then drape it over the existing ground surface. If we see large sections of cut, we can tweak the proposed profile to get a better solution, but hopefully place the proposed profile slightly above the existing. And the color scheme legend in this image, the light blue and the green means we can resurface. The orange would require full depth reconstruction. And it's not surprising that at least a chunk of this orange is right here in the middle, because in this particular example, there was no pavement there. Ended up being kind of a grass median that we had to do. So that wasn't surprising that showed up. But for the most part, the other areas we were able to resurface and do just a little bit of pavement warping, basically. So again, whatever we can do to what I'll call reduce construction costs, but really to improve that constructability. Full depth reconstruction adds a lot more complexity to construction. And then I'm use this time to promote the DDI review process that FDOT Central Office utilizes. So David Amato, you know, as DDIs are going through the internal design process there for Florida, you know, Central Office gets a chance to review them. You know, we're looking for several items, but when we are looking for those, there's certain things that we want to see as part of that review process. One of them is the horizontal and vertical geometry of the DDI. We also want to see the truck turning exhibits because, you know, one of the comments I always give if I don't see those is, are you sure you can turn the design vehicles that are established for this, especially on the dual rights or the triple rights or whatever that we've seen? So showing us that, and make sure you read the FDOT developmental design criteria for DDIs, because there is a specific way that we like to see the pavement widening as a result of the truck turns. The traffic analysis, because we want to verify that we have the right number of lanes, especially through the interchange core, which is the area that I call between the two crossovers. Because if that's wrong, then to add another lane partway through design is a big change. So let's confirm the traffic analysis works. A signing plan is extremely important because we really do want to make sure, especially when you have option lanes, especially when you have, you know, some of these drop lanes, just make sure that we can sign it and that we can sign it far back. And this doesn't have to be a detailed signing plan. Sometimes just a roll plot showing the guide signs would be great. We don't need to see every single ground mounted sign necessarily. We really are looking for some of those more critical signs. And that's kind of where I get, you know, showing a large roll plot schematic of the entire DDI on one sheet is very helpful. So even kind of what you see on the screen right here would be great. It allows us to kind of take that step back and see the whole DDI. Just be careful of where you set your match lines if you end up going to two sheets. So here's a great example of a DDI where we got to review it, that they put a match line literally through the heart of the DDI. And so as a result of this, this was sheet one, this was sheet two. This became really challenging to review. I ended up having to do a little old school of printing this off and taping it together to get it so where I could see the whole thing. So, you know, just something, those are part of the pieces that we definitely would like to see anytime we're doing a review. David, I don't know if there's anything that you wanted to add on that as far as the FDOT DDI review contract.
No, I think you covered it pretty well.
Okay, I put you on a spot a little bit, so I just want to
Yeah.
see. Cool. Okay. All right. So let's hit a little constructability. So we got to talking about, you know, full depth pavement versus resurfacing and all that stuff. And really what we're trying to ease a little bit is not just the cost, but also the constructability. You know, we talk about construction phasing, there's many options for maintaining traffic, and a lot of that is simply just site specific. But one thing that we recommend with our DDIs is to take that weekend before we flip the switch and turn it to a DDI officially, take that weekend and close the interchange. And that allows us to perform, you know, some signal testing, test the signal timing, look at the final pavement markings, you know, that sort of thing. So that goes a long way to making sure that day one when it's open is functioning well, because it is something that, you know, potentially the drivers in the area just don't know a lot about. So there's several questions to consider when we're developing our temporary traffic control plans. You know, the first one, what I always like to ask is, can the interchange be closed? You know, which, you know, the corollary question that would be, is there an appropriate detour available? And one thing I would definitely recommend is maybe don't make a real rash decision to say, well, no, it can't be closed. Confirm with the local businesses and the stakeholders before you decide that. Because there are times where if you present the businesses in the area with the alternative, which is we can do this part width. We have to keep it open. We're going to maintain traffic through it. You're probably going to experience significant traffic congestion. It's going to last 12 months construction, or we can close it and we can get this thing built in 4 months. There are times where the business may say, you know what, as soon as construction starts, we're going to be routing our trucks and our traffic around anyway, so go ahead and close it. That happened to us on a project and saved a considerable amount of cost. So just something to think about when you are asking this question of whether it can be closed is make sure you do your due diligence before you answer that. The next question, is the existing pavement going to be reused or replaced? So again, we've already touched on this a little bit. The difference between full depth and resurfacing is a significant difference with how I handle my temporary traffic control. The duration, the lateral width that I need, the timing, all that stuff comes into play. And then, is additional width necessary to accommodate future traffic? So sometimes you get a DDI that is wider than the existing diamond, so that can be used for, to your benefit potentially. So, those are something to just think about. And then when are the best times to switch traffic between the various stages of the project? So, and really it's a timing question in general. If you got a school nearby, when should this thing be under construction? If you're shifting traffic, if it's in a high tourist area, maybe you're trying to do it at night, but you may have a little bit tougher time depending on when it is. So just being able to answer those questions will be very helpful. So there's several options for maintaining traffic when you're constructing a DDI. The first one here is the closure between the crossover intersections. So what you see in gray would be the construction work zone. And what we're allowing in this particular option are right turns to and from the freeway, but no traffic going through the interchange. So obviously we need a good detour route. Hopefully it's fairly close. Depending on the situation, if you have an adjacent interchange that maybe is a clover leaf, that would help, because now you can get traffic that wants to say come from the north and turn left. Now they can go through past the interchange, go through the clover leaf, come to the south and turn right. Or if you've got a surface street that can use the detour. So this is one option here. Another one is, offline construction, and obviously this becomes very challenging simply because there's usually some elevation cross slope changes throughout the crossover areas, so this is not really that straightforward, but whatever you could do to maximize that offline construction, the better. And then the other option really is that part width construction strategy. Challenge with this is often the number of lanes available in order to construct part width is too low. So let's say, for example, it's ultimately going to be a 6-lane DDI. And if we're building this part width, that means we only have 3 lanes available during construction, right? And if we do that, how do we allocate those 3 lanes? So likely if we're doing 1 lane each direction with a short back-to-back left turn lane, when you've already got probably 2 lanes in each direction and a full length left turn lanes as a diamond, and now you're going down to half that, it's going to be gridlock, or oftentimes it will be. So again, this is where I get back to, let's talk to the businesses, the stakeholders. Let's lay out the different scenarios that you could run into. In this particular case, you're going to see some potentially problematic traffic queues, at this strategy, because you're still operating each of these crossover or these intersections as a 3-phase signal, as you would in a normal diamond. And so you're not really gaining a lot of efficiency by doing that. So, just really quickly, if we're doing a part width construction, existing condition may be something like this, where it's 2 through lanes and a back-to-back left turn lane, so a 5-lane cross section. Phase 1, we're going to maximize the offline construction, which may require some lane closures, but we're going to build as much as we can without disturbing any of the traffic. Phase 2, we may come in and shift the traffic to the north half. We'll construct the south half. But when we shift the traffic north half, we may only get 2 lanes. If it's a 5-lane section, we may only have 1 lane each direction, which is going to be a through and a left turn lane in the same lane. So typically that's too few lanes, and that's going to be a lot of traffic congestion. And phase 3, then we're going to build the other half. And depending on the situation, if we're able to overbuild a portion of the first piece of construction, we may be able to add more lanes to this. But if we're overbuilding, we potentially could be looking at additional cost. And then phase 4, we can shift that traffic to the outer edge to construct that center island. Perhaps this phase isn't needed if we can shift the traffic to one side with enough room to overbuild the other half, and we can get that center island within the DDI constructed as one of the earlier phases. And then phase 5 is where we would do the weekend closure. We'd finish the transition to the final DDI, finish the surface course, the striping. We may have some lanes closed temporarily while we're doing this, finishing the curb, testing the signal. I should say leading up to the weekend closure, we may have some lanes to kind of get this started, some lanes closed. But like I said, a weekend closure is really good just to flip that switch to a DDI. But as you can see, doing a traditional part with construction leads to some challenges of how we're going to maintain traffic. So what if we could gain the efficiency of a DDI earlier during construction? What if we could reduce the number of traffic shifts during construction? Has those become a real challenge, not just from a safety standpoint, but from a cost standpoint? And what if we could educate the drivers on how to drive a DDI earlier? So thinking like that a little bit, what if we operated as a DDI during construction? And so if we did that, and I'm just going to show you a couple little images. This is actually a job that we did in Jacksonville, Florida. And so these first couple were just simply sketches and a couple little bit of drawings that we put together just to try to, for us internally, understand how this would work, especially the crossovers. It's because you're not using raised curb, but you're using, barrels or traffic cones or something to that effect to delineate these crossover intersections. Utah DOT swears by this strategy. They have seen a lot of really good traffic operations during construction when they've used the DDI. So let's look at an example of what we did. And again, this is in Florida, so in Jacksonville. With the north is to the right, the interstate runs up and down in this image, but we actually took it out from the view for better clarity. So in this example, in the existing condition, we have 2 lanes in each direction, plus full length left turn lanes. So it's a 6-lane existing cross section. So if we were to do this part with construction without overbuilding and without running as DDI, you've got 3 lanes, which is likely going to be 1 through lane each direction with back-to-back left turn lane. So if we're looking at it now, phase 1, again, we're going to maximize that offline construction. In this particular example, if you remember that heat map example I showed you, now you can kind of see where that came from. We had to also construct some of the pavement in the median, which required us to narrow the lanes a little bit, add a little bit of temporary pavement. But again, phase 1, we're trying to disrupt the traffic as little as possible. In this particular drawing, the blue is the construction and the orange is the separator between the construction zone and the traffic. Kind of give you a little bit of a context of what you're looking at. Then we come in here in phase 2, and we do utilize part with construction. We construct the north half. That's what you see as blue. And we operate the DDI on the south half. So we're utilizing those efficiencies of the DDI, those free flow left turn lanes, those 2-phase signals, and we're getting a lot better operations at this location using it as a DDI. A couple of things to think about. When you're looking to operate something as a DDI, pay attention to your signal foundations, your the permanent ones, which we'll talk about in a little bit, but also your temporary signal poles. Ideally, what you'd like to do is place those temporary signal poles such that they work for all your phases, and that you can just slide the signal heads along the span wire as opposed to moving poles. So just be cognizant of where you can put the temporary signal poles, or if you can utilize some of the permanent locations, that would be great too. So then phase 3, same thing, part with construction. Now we're constructing the south half. We're operating the DDI on the north half, the pavement that we've already constructed. And I wanted to show just real quick that, through all of these, minor lateral shifts of the traffic to accommodate the left turn movement through the work zone would need to be done. So, that's just something that we have to be mindful of. You're trying to build that blue while you've got a ramp that cuts through there, so you may be shifting that ramp a little bit each way. And in phase 4, weekend closure, we finish that transition to the final DDI. We finish the surface course, the striping, and we test the signals. So, and the benefit of this simply is, 1, better traffic operations, 2, phase signals, free flow left turns, but you're reducing that learning curve to the drivers because they're navigating a DDI during construction when speeds are typically lower anyway. Speeds are lower, people are kind of paying a little bit more hypersensitive to what's going on because there's construction vehicles, there's orange barrels, and so you're essentially teaching them without them knowing it. So it can be a great public education tool as well during construction. So then, of course, gets me thinking a couple times, what if we could gain the efficiency of a DDI even if a DDI isn't being constructed? And what if we could operate as a DDI for a bridge replacement project, for example? So is there anything stopping us from doing that? So here's a good example. So this one is a job, not in Florida, but what you'll notice by this image is, the Google Maps drawing shows very clearly that there is a high volume of left turns being made both directions onto the ramp. What this drawing doesn't show is how heavy the through movement is as well. And so it's a 6-lane cross section. We have several truck stops on the east side. We have a very large outlet mall. On the east side, we've got a ton of businesses on the west side, a lot of traffic that funnels through this interchange. There's future plans to construct a new interchange about 2.5 miles to the south. That's going to alleviate a lot of burden at this interchange. So the client doesn't want to put a bunch of money at this location, but we need to replace this bridge. Or not replace the bridge, we just need to redeck the bridge. So the challenge with that is, redecking the bridge means you're taking the bridge out of commission. So it's a diamond interchange. So existing condition, 2 through lanes, each direction, back-to-back left turn lanes. So if we look at potentially operating this at DDI during construction, phase 1, we use the existing intersections to create the crossover intersections. Here it's a little bit easier because we're really not doing a lot of pavement work outside of the bridge. The bridge is just getting redecked. So I've got that width and I've got that area to be able to establish the crossover intersections. And in this particular case, I can construct the southern third of the bridge. Depending on the choice that was selected, I actually could have reduced my lanes to a 3-lane section, and I could have done half at a time. In this particular case, the blue represents the lane closed, and I'll explain why in a second. The green is the construction this phase, and the orange you'll see in the next drawing is the construction in the previous phase. So now we're in phase 2. Again, we've got that DDI for the 2 crossovers, and now we're building the construction in the middle, and then we've got traffic on the outsides, either on the new bridge deck on the south side or the existing bridge deck on the north side. And again, if we can get away with less lanes, we could actually do this in 2 phases instead of basically 3. So here's my 3rd phase, where again, I'm looking at constructing the north half, and I'm putting all the traffic on the south half on the new deck. And then the final condition, I go back to a traditional diamond interchange. So when I'm all done, the DDI is done. We've removed all the barrels, and we go back to just an existing diamond, same typical section, same cross section, same bridge. It's just a new deck. We learned a few lessons on this job though. And the first one is watch the truck turns. And this is no different than any DDI design, but you definitely notice it when you're looking at, something like this that's very innovative. So we wanted to minimize the temporary widening because on this particular job, remember, the client didn't want to put a lot of money into this project. So what you can see by the red box, this interchange was, so in the southbound direction coming off the freeway was a dual right and a dual left. And what we had to do on this job is make it a single right and a single left. Now, again, remember, it's now a two-phase signal instead of a three-phase signal. But the reason why we had to make it a single left is because we had to push that left turn lane far away from the center of the interchange so that the truck turns could actually be done and completed in the existing pavement to make that turn to that north half of the bridge. So that's just something, always run your truck templates, especially in an MOT situation. So that's the reason why those two lanes were closed and we changed the striping. One of the other challenges when you do this, how do we message this project to the public when it operates better during construction than after, which is what happened on this particular job. So now the client's actually looking at this and saying, what would it take to make this a DDI permanently? So just that is something you have to think about, but at least in this particular case, it worked really well. A couple of other things just to touch on the constructability side. One practice that can be easy to avoid and painful to the construction schedule if it's not. So this drawing shows the proposed DDI schematic with the existing DDI interchange shaded in yellow. So these circles right here are the proposed signal pole locations. Note the number of foundations that are in the existing pavement that would be difficult to construct, especially with the lead time that we have on signal poles. That could be a real heartache to the schedule. So what if we just took these poles and relocated the outside? So here's a good example of one right here. So the left image, if we just move that signal pole foundation to right there, where that green is now showing, we can still show what we need to, but now it's outside of the existing pavement and outside of the proposed pavement. So I could start building that very early in the construction process. And the same thing with this one right here. You could just move that pole to the outside edge right there, that green, and do the same thing. Now, obviously, you got to be mindful of the offset from the overhead signals to the stop bar. So just being careful about where that stop bar gets placed. But we be mindful of the existing pavement when we're laying out the signal plan. And I would also say same with the overhead sign foundations. And so creating a drawing like this with that yellow, just very clearly shows where the existing pavement is very beneficial. And it'll allow you to kind of track where your foundations and where your poles are located. And this is another example, of a proposed DDI. So the first thing, let's look at the existing pavement. That shows up in yellow. And then if we look at the signal poles, those are showing up in green. Notice that they're outside the existing pavement while still functional for the DDI. So this was a good example of where you could actually start constructing those foundations, those poles, at the same time you're building the pavement. The last thing on the constructability, I think it's the last thing that I'm going to touch on, is concrete pavement. So if you have concrete pavement, be mindful of your pavement joints. This is a topic that we got taken to task a couple times by contractors on this particular job. So what you see in yellow right there are all the pavement joints that were constructed for this project. And this was the contractor, after arguing with our pavement joints, came back with his own. And 8 months after this project was open, I don't know if you can see it on this image, but the pavement joint already failed and there's a huge crack, huge chunk of pavement out. And then this particular crossover intersection, hopefully you can see it, and the yellow highlights are all of the pavement joint layouts, or all the pavement joint locations. Um, the challenge you run into is these acute angles. When these pavement joints come to a triangular point, that becomes a real challenge. They don't stay together very well, especially with the angles that the traffic is moving over across them. They're not perpendicular to these joints because of the acute angle of the intersection. So Utah DOT, back in June of 2014, put together a concept in their best practices, their DDI guidance document for how to handle pavement joints. But you'll notice that even with what they did, they've got some triangular pieces there that are going to be very hard to maintain. But the one nice thing about this layout also is there's a pavement joint that runs right down the center. I don't know if you can see my cursor, but right down the center through here, which lends itself well to that part width construction of the DDI. So just something to play with, something to think about. This is a challenging area as well. David, do we have any questions?
Yeah, we got some questions actually from the last session.
Okay.
One on signing. Is it easy to get sign overload, and what can be done to mitigate excessive signing?
Yeah, I mean, that's a great question. I kind of liken this to a roundabout as well. You can have a lot of visual noise if you're not careful. There are definitely some good strategies. I think we covered this a little bit during the signing and pavement marking webinar that was, I think it was a couple sessions ago. But I mean, where can we maximize the effectiveness of the signs? Is there places where we can kind of put it all in one area rather than spread them out throughout the interchange? So there are definitely some strategies that can be done.
Okay. One more question. Will the next gen plan sheet size help with the match lines? I think that was talking about when we had a match line running through the middle of the DDI. And I think the answer to that is yes. Next gen, I think there's more flexibility and you can get more of the project on a single sheet, I believe. I'm not an expert on the next gen.
Yeah, but you're absolutely right. The next gen plan sheets, they're looking at larger sheets now,
Right.
and a little bit more content, or a little bit more coverage, which is always good. One of the things that it may be a situation where if you've got a plan set that's got 50 scale plan sheets all the way through there, can you also create a roll plot, even if you have to scope that, but just for reviews, if you're not doing the next gen sheets at this time or something. But
I think we're all caught up on the questions.
excellent. All right. So public involvement. This is always a fun topic. I think I'll start though first with the public education piece of it. And my first word of advice is don't reinvent the wheel. There's been a lot of information that's been created. I mean, you could literally just go and Google DDI, diverging diamond interchange, public education. You could, how do I drive a DDI? And there's a lot of information. This particular screenshot that you see up here is from the state of Washington. It was their first DDI, and they put together a real nice 4-minute video that shows, what a DDI is and how to drive it. So, something like that, you could pretty much just poach if you wanted to, especially for a meeting, just to be able to show somebody. Obviously, if you want to create one that's site specific, which is usually what a lot of people like to do, that takes just a little bit of cost, but something that you may not have to do. Georgia put together a very proactive public outreach campaign for their first DDI. They had a lot of keys to success. They had one, it was kind of a cool little catchphrase: can you DDI, arrive, crossover drive. The media campaigns, the transparency to inform and educate the public. They had active and ongoing participation in town halls and meetings. They were very involved with engaging the stakeholders and the businesses to get their engagement, their buy-in, and their promotion. Those stakeholders became the champions for the project, and that partnership really was the key. But you know, that's just one example. There's several examples of this public education, you know, opportunity or strategy for DDIs. The nice thing too is, you know, there's so many now in the ground that, and there's so many states that are doing even their first ones that, you know, there's a lot of examples to choose from. And then we talk about public involvement. One of the things that we want to do is we want to keep it simple. The public is not typically the engineers. You know, they're not engineers, they're not traffic analysts, even though everybody who has a driver's license thinks that they are a traffic analyst. You know, most of the time we go to the public meeting or the stakeholder meeting with really pretty exhibits like this one, showing a nice top view of the whole interchange reconfiguration. Problem with this strategy is that many people see these and they're immediately confused or can be overwhelmed by what is happening. And this is often the case, you know, with innovative solutions. So one of the examples I had at this particular project is I had a lady that came up to me and she was just dead fast against this concept, the DDI. She was worried about the confusion, and specifically she pointed to my map and she said, when I'm sitting here where the yellow arrow is, so when I'm sitting at this ramp location, there's going to be so much confusion. I mean, I got traffic on the other side of the bridge over there. I've got traffic on the other quadrant that's coming at me. It's going to be very confusing. And, you know, it's hard. You're trying to kind of explain to her what she's probably going to see. And finally, partway through the explanation, where I kept looking at the blank stare she was giving me, I just opened up my laptop and I went into Google or YouTube and I just pulled up a video and I showed her, here it is, exactly at that same location she pointed to. And I showed her what she could see. You know, this is a driver's eye perspective of that particular location that has been created. It's on YouTube. You know, it didn't cost me any additional money to build models and that sort of thing. So, you know, and then as we're coming around through, you know, this shows again that perspective, you know, showing even the drivers on the left side, you know, or I should say the drivers on the right side, if you will. So you're on the left side of the road across the bridge, but again, it's intuitive, following the leader. It should not, a good design should not alarm the public. You know, again, this is throwing it through the core of the DDI. And then, you know, there's Vista models, the animations, they're good to supplement some of these top-down images. These animations can show how traffic moves through the interchange, and it's something the public can often better understand. This particular video here, which I'm not going to play because I don't think we have a lot of time, but it shows not only the cars going through, it also shows pedestrians. So this is sometimes a really nice way to convey how a pedestrian would travel, especially when you tell people that you're going to put a pedestrian down the middle of the DDI. That in itself, just saying that statement, often will probably add a little bit of stress to their lives, thinking that they have to walk in between cars. So you have to show them how safe that environment can feel. Especially when you put that barrier separation, you give them that wider path. So, and when we're talking to the public, we want to focus on the advantages of the DDI, but remember that, you know, sometimes getting into, oh, this reduces the number of conflict points. That may, you know, that's something engineers like to talk about, but it's not always something that the general public understands. And so, you know, we want to make sure that we're emphasizing increased safety and improved traffic flow, but we're putting in that perspective of, you know, you can get through this interchange better. You can get home quicker. You know, if there's crashes, they're less severe, which means you can walk away from them. Those are the things that we want to message. You know, describing how they're functional for all vehicles and all modes of travel is a huge benefit, especially when you're talking about pedestrians and how they're going to navigate through here, bicyclists, that sort of thing, which we touched on 2 weeks ago in the multimodal piece. And I think when you're talking about their cost savings, you know, if you just say, well, this interchange saves $3 million, they may be a little numb to that because they're like, well, you're the state, you can afford all this stuff. But if you put it in the perspective of this gives us more money to apply to other locations, to other congested corridors, so that you can continue to see improvement on your commute. That type of messaging kind of goes a long way when you're talking to the general public. So David, I don't know if now we want to open this up. We only have about 5 minutes left, but is there any other questions that are in there or anything that we can tag to the cleanup?
There's one really long question. I guess I can try to read it real fast. We had to work on a DDI project where the existing interchange was a spread diamond. The district kept existing off-ramps, on-ramps, and created a DDI. This posed a problem by creating 2,000 feet spacing between crossover. Vehicles accelerate on the tangent sections of the DDI anatomy and cannot negotiate the crossover left turning maneuvers. FHWA recommends the spacing between crossovers to be 500 to 900 feet. Can this be enforced by the CO and included in the FDM? It helps the signal timing phasing as well. So you want to talk a little bit about the spacing between the crossover intersections?
Yeah, I mean, I think it's an accurate statement that the larger the DDI, sometimes the harder it is to manage speeds. You know, they get through the crossover intersection and now you've introduced a very long tangent for them to accelerate in. One of the things, if you go back and if you remember what we talked about for the geometric design, is what I call the Q-tip. It may be worth, in this particular situation, introducing that Q-tip, where when you get inside the interchange core, you've introduced some reverse curvature to bring the two directions of the roadway closer together. Because what that does is by introducing that curvature, you're continuing to kind of promote that slower speed for a little bit longer into those tangent lengths. And so now instead of 2,000 feet between the crossovers, maybe you're at about 1,300 feet by the time you got through the reverse curves. So and that would help certainly, you know, but that is something that you want to be mindful of, is how fast do you think drivers are going to accelerate. I do honestly believe that signal timing and everything else, you can kind of adjust a little bit to promote the slower speeds if you need to. People don't want to race all the way through there if they're going to just come up to a stop. So David, I don't know if you want to tag on or.
No. Couple more questions. Is the profile through the crossover section typically at spline grade? I'd like,
Yeah, and that's a great question. It often depends. Again, when you're setting your proposed surface, you're essentially, what I typically do is I create profile for, say, one alignment, one direction, and then I kind of drape the next one over top of it to kind of see where it lands. So you end up with, I think spline grade is probably a fairly accurate statement. You end up something that maybe looks a little bit like a proposed or an engineered profile, but not exactly. And then what you end up doing to some level is you start kind of massaging the two to get them to where they both really could be functional as engineered profile grades, but still get that warped pavement, get that cross-slope, get that drainage to work. So, and that's usually just something, again, with our proposed surfaces, you can kind of create that, drape the one over the other, and kind of get a good handle on what it looks like. But you may end up with something that I think you're calling spline grade. I've called it graphic grade before, that sort of thing. But yep.
right. Okay, looks like we're pretty much out of questions and we're pretty much out of time. So I want to thank everybody for joining us. If you were not able to attend some of the earlier sessions and would like to listen to them or download the slides, we have them posted on the Roadway Design Office website in the training page. So again, I want to thank you, and that should conclude the webinar and the series.
Yes. Thank you, everyone.